This is for Year 11 methods, the theory for exercise 3C, solving quadratic equations. So in the previous exercise 3B, you would have learned about factorization. We're going to put factorization into practice and use it to solve for quadratic equations. So the basics of solving quadratic equations is we need to know the null factor law. The null factor law states that if we have a times b and that equals 0, then either a equals 0 or b equals 0, where a and b are real numbers. So you can think of, when we're solving quadratic equations and we set the t equals 0, we can think of that as trying to find the x-intercept. When you set y equals 0, that's where the 0 comes from. Okay, so basically, if I have a quadratic equation in factor form, we've got in example 1, x minus 1, x minus 2 equals 0, then we know that this brackets times that brackets equals 0. So by the null factor law, we know that either the first factor equals 0, so x minus 1 equals 0, or x minus 2 equals 0. Then we can solve based on that equation. So we can go, and that's an or. So we can go x equals 1 or x equals 2. And you'll find out later when we do graphing quadratic equations, that's where the x-intercept occurs, or where the graph cuts the x-axis. In example 2, we've got 2x minus 3 equals 0 or x minus 4 equals 0. Again, by null factor law, either the first factor equals 0 or the second factor equals 0. So 2x minus 3 equals 0 or x minus 4 equals 0. So when I rearrange it to solve for x, I get x equals 3 on 2 and x equals 4. In example 3, we have something equals something, but we don't have any zeros. So how I create the 0 is I subtract 25x off both sides. So I can get 5x squared minus 25x equals 0. So then I factorize. Remember, the skills you learnt in 2B would be utilized here, where we try to find a common factor. A common factor would be 5x. So factorize 5x, and we've got 5x times brackets x minus 5 equals 0. So again, by null factor law, I can go, if I have something times something equals 0, then the first something equals 0, or the second something equals 0. So in the first something is 5x, that equals 0. The second something is x minus 5, and that equals 0. So we can solve for x, and we get x equals 0 or x equals 5. In example 4, we have something similar. Now, for example 4, I can do it two ways. I can take the square root of both sides. Remember, when we take the square root of both sides, we have to get the positive and negative root. So we get two solutions. Now, or I can do it the factorial way. So I minus 64 of both sides to get all the terms on one side and the 0 on the other. Then I recognize this as dots, difference of two squares, because we've got something squared minus something squared. So that can be factorized into x minus 8, x plus 8 equals 0. I use the null factor law. X minus 8 equals 0 and x plus 8 equals 0. So when I solve it, I get x equals 8 and x equals negative 8. So for the next example, we've got a situation where we have to factorize a monic quadratic equation. It's monic because the coefficient of x squared is 1, so it's one of the simpler factorizations. We use cross products, remember? We need two numbers that times together give you 24 and add together to give you negative 14. So they have to satisfy that condition. So I use cross products. I found out all the combinations that give me 24, but add together give me negative 14. And the combination I found was negative 12 and negative 2. So I factorize it accordingly, and I can then use the null factor law to solve it. So again, either x minus 12 equals 0 or x minus 2 equals 0. So therefore x equals 12 and 2. For the next one, Now this one's a non-monic type of factorization that we need to do, because we've got 5x squared plus 7x minus 12 equals 0. So we want to get it into factor form so we can solve for when x equals 0. So I use the cross product way. So with this one, you can have a gazillion possibilities. Look, you do not need to write all the possibilities if you know what you're doing. So once you do more of these, you get a feel for like which numbers to choose, which numbers are sensible. So you can rule out some of these straight away and not even write them. So you choose the most sensible numbers for your factors. So what I've found was that 5x -1, 5x times -1 plus 12x gives me 7x. So that's the only combination that works. So remember, you read across from. So I read across from here. We've got 5x here, and we've got 12. So 5x and 12 go together. X and -1 go together, and that equals 0. You can always check by expanding again to see if you get that solution. Now, again, we use the null factor law. Either that equals 0 or that equals 0. So 5x plus 12 equals 0, or x minus 1 equals 0. And then I solve for x. So I subtract 12 from both sides and then divide by 5. So again, x equals -12 on 5, and x equals 1. Now, worded problems. So quadratic equations serve a purpose in that they can be used to solve for a real life context. In this case, I'm going to give a quick example from the book. The altitude of a, so this is question 11 from exercise 3C. The altitude of a triangle is 1 centimeter shorter than the base. If the area of the triangle is 15 centimeters, calculate the altitude. So first of all, worded problems, understand context and draw a diagram. So I drew a triangle. The altitude is like the height. We know that's 1 centimeter shorter than base. So if the base is x, then the altitude or the height is x minus 1. Now we know that the formula for the area of a triangle is half times base times height. So we know the area is 15, it's given to us, and it equals the area, which is expressed in terms of x, half times x times x plus 1, which is the height. Okay, I expand it, I move all the terms to one side. So why do I want to do this? Remember, I want to factorize and solve for when x equals 0, okay? So, so I factorize this. So I use cross products. Again, you can go x, choose two numbers that work. So there are various combinations of 30. You can use 3, 10, -3, 10, 5, 6, -5, 6, and so on and so forth. What I found was that x times -6 is -6x, plus 5x is -1x, so that one works. That's why I factorized it in x minus 6 and x plus 5. So therefore, I get the solution. So when I solve that, I get either x minus 6 equals 0 or x minus 5 equals 0. So I solve for that and I get x equals 6 and -5. Obviously, this is a real life context, so you need to think. You can't just go, oh, I've got two solutions, I'll accept both of them. Remember, x represents a length. So, well, a length and a base. A height and a base. So, x can be 6, but it can't be -5 because that doesn't make sense. So you have to outline the reason why you're rejecting the solution. So I rejected x equals -5 as x is greater than 0. So solution rejection. Yep, the solution rejection step is important. So therefore, x is 6 centimeters. Have we answered the question? Calculate the altitude. No, we just found the base. So the altitude would be 1 less, which is 5 centimeters. Hopefully this will give you an idea of how to do exercise 3C. So when you're in trouble, make sure you move all the terms to one side and you have a 0 on the other side, and then factorize. Enjoy.